Hey guys, got some practice problems for you. I've pulled, I think I got 7 problems here that I grabbed from old AP exams, so old AP calculus exams. So you can see that what you're doing is not just, calculus introduction, but it is actually calculus. So the calculus exam is calculator and non-calculator. The first half of the multiple choice, it's a little more than half of the multiple choice exam, is non-calculator questions. So question number 1 on this exam was a limit question where x is going to infinity, and this was a non-calculator question. So I'm gonna pause it so you can figure this one out. All right, how'd you do? Did you get it? So if we're heading off to the right-hand side of the graph, then we see, oh, this is just an end behavior question on a rational function. So really, I just need to figure out what the degree at the top and the bottom is. So I see, ooh, horizontal asymptote. Horizontal asymptote, and this one would be y equals, all right, the numerator is a squared. So I don't need to multiply it all out, but if I did 2x times a negative x, that would give me a negative 2x squared. I don't care about what the rest of it is because I really just need the leading coefficient. In the denominator, if I did an x times an x, that would give me an x squared. Again, there's more on the top and there's more on the bottom, but I don't really care. I just need to focus on that horizontal asymptote, which is a horizontal asymptote of y equals negative 2, which means that my limit is heading to negative 2. That's the horizontal asymptote. Okay, alrighty, I got the next one's over here. All right, so for this one, this is not quite x going to infinity or x going to negative infinity. This is kind of going back to what we've done before. So we would try a direct substitution. If I did a direct substitution, that would give me 5 times 0 to the 4th minus 8 times 0 squared over 3 times 0 to the 4th minus 16 times 0 squared, which of course gives me 0 over 0. And hopefully you remember from last week that 99% of the time that you get 0 over 0, the limit does exist. It's just going to require a little bit of algebra for you to figure that out. So like in the numerator, you could factor out an x squared, and that would give me a 5x squared plus an 8. In the denominator, I could factor out, I guess, just an x squared again. That would give me a 3x squared minus a 16. This is good because then the x squareds are going to be able to reduce, leaving me with 5x squared plus 8 over 3x squared minus 16. Really, I should attach the limit again. Like, I know this is just, on this exam, this is just a multiple choice question. But the thing about calculus is you also will have free response questions, just like every other AP exam that you would ever take. So that just requires you to communicate with your math. So I'd have to rewrite that limit. Let me try direct substitution again. It shouldn't give me a problem now. 5 times 0 squared plus 8 over 3 times 0 squared minus 16 leaves me with 8 over negative 16, which is negative 1/2. Okay, moving right along. I think I have another one over here. Alrighty. This one's kind of tricky. I'll start this one out with you. So if we're looking for horizontal asymptotes, now the thing about horizontal asymptotes is only in a rational function will you have just one horizontal asymptote. If the function's not rational, this one's not a rational function. It's rational in nature, but it's not a rational function because by definition, a rational function has to be a polynomial over a polynomial, and something like 2 to the x is not a polynomial. So for horizontal asymptotes, that's end behavior. So this is testing you at this point in the exam. Do you remember that horizontal asymptotes are really limits as x goes to infinity of the 5 plus 2 to the x over 1 minus 2 to the x, and then limit as x goes to negative infinity of that same function. This one's actually kind of tricky all the way around. All right, so when x is going to go to infinity in the first one, then again, thinking of this like plugging in, this would be like 5 plus 2 to the infinity over 1 minus 2 to the infinity. These things right here, let's use this guy. That's just going to be going to an infinite value and an infinite value. So that means that really this is like 5 plus an infinite number over 1 minus an infinite number. And when that happens, there's actually more. You would, in calculus land, you would do this without a calculator, but I want to show the calculator on this one. Let me grab that 2 to the infinity back here again. So I'm going to come back to that one. Give me a second. On the second one, if I, again, think of that infinite value being plugged in here, this would be 5 minus, excuse me, plus 2 to the negative infinity over 1 minus 2 to the negative infinity, which means that technically, remember, exponents that are negative, it's really like saying 1 over 2 to an infinite value. So that's how you make the exponents positive. And now, if this is really like 1 over 2 to the infinity, that's like 1 over a very, very, very big number, because 2 raised, like that's 2 times 2 times 2 times 2, an infinite number of times. That means that this is really heading to 0, and same thing, this is really heading to 0. So really, my limit here is heading to 5 plus 0 over 1 minus 0, which means that I have a horizontal asymptote of y equals 5 as I let x go to negative infinity. That's the left-hand side of my graph. So that means I can go ahead and eliminate this one and this one and this one. So now it's down to, is y equals -1 also 1? So again, this is a non-calculator question technically, but because you don't know enough calculus yet, you wouldn't be able to do the positive infinity one easily. So I'm going to grab my calculator here for that one. So it was 5 plus 2 to the x over 1 minus 2 to the x. That was the problem. Let me just look real quick. Yes. Okay. I don't even really need to look at the calculator. Let's just go to the table. We've already got it going to infinity here. So I see that it's going to be like negative 343 over 341. That's pretty close to -1. This is -1. We're getting too far where it's hard to see. Guess we can try and look at the calculator, the graph, see what it looks like. Here's my horizontal asymptote on the left, heading off to y equals 5. On the right-hand side, heading off to a positive infinity. It looks like it's heading off to a y value of 0, which obviously a y value of -1, which it is, but calculus-wise, just can't do it yet. But the answer to this one, like if this was the exam, would be y equals -1. But for you guys, you know, I really just wanted you to think of that fact that horizontal asymptotes are the same thing as a limit. That's why this was a calculus question. Okay. All right, I want you to think about this one. Or answer it, actually. All right, so this one's tricky because it says which one of these statements is false, and AP exam sometimes will be a little tricky in that scenario because if you don't look carefully, you might grab the first one that you see is right. All right, so we want to know if the limit, that doesn't say what it is, but the limit is x approaches 2. So as I get close to 2 from the left-hand side, my y values are heading towards a y value of, looks like 2. And as x approaches 2 from the right-hand side, my y values are also heading to a y value of 2. So both left and right-hand sides are going to be true. So that does exist. It's actually equal to 2 if you really want to know. Okay, second one, as we approach 3. So now, let's ignore that. Let's let x approach 3. So approaching 3 from this side and 3 from this side. Looks like y values are both heading to a y value of 5. So that one exists. It's heading to y value of 5. Okay. What about as I head to an x value of 4? So head to 4, head to 4. Ooh, this one's going to be a problem. So I'm heading to 2 from the left, and I'm heading to 4 from the right. Does not exist. Answer should be C. And then same thing as you're going to approach 5. Just I'll throw that last one in there real quick. If you're approaching 5, both the left and the right hand side, you're just heading to this y value of 6, going to the same place. So answer should have been C. Hope you got that one. Okay. All righty. How'd you do? Did you get it? All right, so hopefully you could have eliminated some of them. B is a linear function. There is no horizontal asymptote. That's just a graph y equals 5x. C, the horizontal asymptote would have been y equals 0 because the degree of the bottom is bigger. D, the horizontal asymptote would have been y equals -5 because I would have done leading coefficient over leading coefficient. So that one would probably been a good wrong answer. If you're not careful, you might have just said 5 over the 1. E is the right answer because we do the leading coefficient of 20 over the leading coefficient of 4, which is 5. So that's why E was the right answer. A is not a rational function, but when you let when you do the limit as x approaches infinity or even negative infinity, the numerator is just going to oscillate back and forth between -1 and 1. So we're just going to keep going up and down between -1 and 1. So your y values are never going to be smaller than -1 or bigger than +1. But your denominator is going to get really, really big. So again, if you're just going back and forth between a y value of -1 and 1 for the top, and your denominator is going to get really, really big, this horizontal asymptote would have been y equals 0. So that's why the answer is E. Okay. Next. All right, so hopefully you didn't forget you've got to check both the left and the right hand sides. So if we got a piecewise defined function and we're going to have a break at 2 like we do here, then I'm going to have to do the limit as x approaches 2 from the left. And I'm going to have to do the limit as x approaches 2 from the right. So this is not all, you know, straightforward. So when I approach 2 from the left, that'll be my upper one here, this natural log of x, because that's used from 0 to 2. So when I get closer to 2 from numbers that are smaller than 2, then I can just substitute into the natural log. Oops, still on the highlighter. I can just substitute into the natural log. That'll give me the natural log of 2. That's not a problem. Remember, you can't plug in negative numbers or 0 into a log. And logs and exponential functions come up all the time in calculus. So that's why we will review it one more time after we're done with limits. All right, approach 2 from the left-hand side. I'm sorry, from the right-hand side. So that'll be this second one here. So I can just do a direct substitution. So that'll be 2 squared times the natural log of 2. That'll be the natural log of, whoops, forgot my 4. That'll be 4 times the natural log of 2. And they are not going to the same place. Limit does not exist, or this particular exam, they said non-existent. Again, that's just a language thing on textbooks. Okay, I think I have one more here for you. All right, this number jumps quite a bit, so that just means that this would have been a calculator question because this is the second part of the exam, or the second part of the multiple choice. But calculator wouldn't have helped you anyway. So if I try and do a direct substitution, in this case, A is just a number. So if I try to do a direct substitution, that'll give me, whoops, that'll give me a squared minus a squared over a to the 4th minus a to the 4th, which gives me 0 over 0. Remember, 99% of the time, that limit does exist. So we can try and factor. The numerator is the difference of squares, but the denominator is also the difference of squares. And if you don't factor the numerator, then you will save yourself some work. So in the denominator, this is really like x squared, and then a squared, That's how I'm getting x to the fourth, a to the fourth. So really the thing that's being squared is just the x squared and the a squared. So I could factor that to be x squared plus a squared, and then x squared minus a squared. So the reason why I'm saying it would save me some work is because I could then reduce these here. If you didn't do that, I'm just gonna keep going and show you if you didn't do that and you had factored the numerator, then that would have been x plus a, x minus a. And then you can't do anything with x squared plus a squared. Sum of perfect squares is never factorable. And then the x squared minus a squared again would have been x plus a, x minus a. So either way, I'm still going to be getting rid of all those things. So that leaves me with 1 over x squared plus a squared. And I'm going to go ahead and toss my limit back on here again as x approaches a. And I'm going to plug, do a direct substitution in for x. So that'll give me 1 over a squared plus the a squared, which is 1 over a squared plus a squared is 2a squared. And that's why the answer was B. Alrighty, hope you enjoyed that, seeing some calculus problems from an exam. Kind of cool, right? All right, I think it's cool. You guys might not.